Welcome to The Explainer. Today, we are diving deep into one of Python's most essential tools, functions. And you're going to want to stick around because we're also going to uncover a pretty surprising hidden power of a built-in function you might think you already know, type function.
So, here's what we're going to cover. We'll start with the real basics, what functions are and how to pass data around. Then we'll switch gears and meet the type function, where we'll look at a super common mistake people make and then reveal a secret identity it's been hiding all along.
You know that feeling, right? When you're coding and you realize you've written the same exact lines of code over and over again. It's a universal pain point for developers.
I mean, take this. You need to sing Happy Birthday 3 times. Sure, you could just copy and paste the code, but imagine this was hundreds of lines long. It gets messy fast and becomes an absolute nightmare to update. But thankfully, there is a much better way.
And that's exactly where functions come in. They are the perfect, elegant solution to this whole problem of repeating yourself.
So what is a function really? Just think of it like a named package of code. You write the code once, you put it in a box, you give that box a name, and then whenever you need it, you just shout out its name or call it. And making one in Python is super simple. It's like a 3-step recipe. First, you use the keyword def. Second, you give your function a unique name with some parentheses after it. And third, all the code that goes inside that function gets indented underneath. That indentation is key. It's how Python knows what's part of the function.
So let's go back to our happy birthday problem. See this? We've bundled up all those print statements inside a function called happy birthday. Now, instead of all that repetition, we just call the function 3 times. Look how much cleaner that is. It's shorter, easier to read, and way easier to manage.
Okay, so that's pretty cool, but functions that do the exact same thing every time have their limits. What if we want to make them more flexible? Well, we can, by sending data into them when we call them.
To get this, you just need to know 2 key terms. An argument is the actual data you send in, like the word bro here, and the parameter is the placeholder variable inside the function that catches it. Think of it like this. The argument is the ball you throw, and the parameter is the glove that catches it.
And you're not limited to just one. Here, our happy birthday function is set up with 2 parameters, name and age. So when we call it, we can pass in 2 arguments, like Steve and 30. The function then uses those specific values. This makes our one function incredibly powerful and reusable for all sorts of different inputs.
So functions aren't just a one-way street. We can send data in, but they can also do some work and then send a result back out to our main program.
We do this with something called the return statement. The moment Python sees return, the function stops and sends a value back. The best way to think about it is that the function call itself literally gets replaced by whatever value it returned.
Check out this example. The createName function takes a first and last name, capitalizes them, and then returns one single formatted string. And see what we did? We captured that returned value in a new variable called fullName. The function did the heavy lifting, and now we have the result ready to use for whatever we want.
All right, we've got a handle on building our own functions. Now let's switch gears and look at one of Python's most useful built-in functions for figuring out what our data actually is. Let's meet the type function. Simply put, type is like a detective for your code. You hand it any piece of data, any variable, any object, and it tells you exactly what kind of thing you're looking at. Is it a number, some text, something else? Type knows.
For instance, if you give it a whole number like 5, boom, it comes back and tells you it's a class int, which is short for integer.
If you give it a number with a decimal point, yep, it correctly identifies it as a float.
And, as you probably guess, anything in quotes is a string, or str. It's a super fast and easy way to inspect your variables, especially when you're trying to hunt down a bug.
But here's where people often get tripped up. Type is fantastic for inspecting things, but using it to check if an object is of a certain kind can get you into trouble, especially when you're dealing with something called inheritance.
Okay, so let's imagine we have a general animal class, and then we have a more specific dog class that inherits from animal. This means that every single dog is an animal, right? That relationship is the key. Now watch this. If we use type and ask, is my dog object an animal, it says false. Why? Because type is a strict bouncer at a club. It's looking for an exact ID match, and our object's ID is dog, not animal. But look at is instance of. It understands the family tree. It knows a dog is a type of animal, so it correctly says true. So, here's the bottom line.
You should use type when you absolutely must know the exact class of an object, which is mostly for debugging. But for almost everything else, when you just want to know if an object fits into a certain category, is-instancing is always the right tool for the job.
And now for the final twist. It turns out that the type function has a secret identity. It has a second, much more powerful job that gives us a peek into just how flexible Python is under the hood. So, we've been using Form 1 this whole time. You give type one thing, an object, and it tells you what it is. But there's a second way to use it. If you give type 3 specific arguments, a name, a list of parent classes, and a dictionary of attributes, it doesn't check a type. It actually creates a brand new one from scratch.
I know this code looks a little wild, but just look at what's happening. We are calling type with 3 arguments to create a new class, live, right in our code. We've just built a class called myClass that has an attribute x with a value of 100, all without ever using the class keyword. It's like a pop-up class factory.
This is a tiny glimpse into a really advanced topic called metaprogramming, the idea of code that can manipulate other code. And it leaves us with this final fascinating question to think about. If the very same function we use to check what something is can also be used to create what something is, what does that tell us about the nature of code itself in Python? Thanks for joining this explainer.